Recording started. Share my screen. All right. So this is session 2. Today we're just going to be going over motor and sensor control. So I'll have a demonstration here on how to program a ultrasonic range finding sensor along with how to interface with a servo motor. Also going to have a quick introduction to libraries and then a little more into the electrical safety. Yeah. All right. So a library is essentially just a pre-written set of code that contains functions that can be used for different things. So a good example of a library is the servo library that we use to control the motors and servos on robots. Libraries just allow for faster development and less complexity because you don't have to look at all the low-level hard math that's already been done for you. Most Arduino libraries include examples. We'll go into that a little later, but these are very good if you're just trying out a new sensor, new hardware, just to make sure everything is working. And chances are, if you want to interface a sensor or another piece of electronics to the Arduino, there's probably a library that's already been written for it. So there's a few things you need to keep in mind when interfacing Arduinos with sensors. There's a few different interfaces that are common. So stuff like limit switches and buttons and some proximity sensors just have a simple on or off. So they'll just give you a simple either 0 volts or 5 volts. An analog sensor, that's just a sensor that gives like an analog range from 0 to 5 volts or 0 to 3.3 volts, depending on what power it runs on. But these essentially just say if it's a temperature sensor, 70 degrees might be at like 2.5 volts, whereas 100 degrees might be closer to 3 and 30 closer to 2. And then there's serial. Serial is probably the most common type of protocol. So there's a few different types of serial protocol. There's something called I2C, UART, and SPI. UART is essentially just standard serial. It's like as basic as it gets. I2C and SPI are two of the more common ones. They're used for sensors, stuff like rangefinders, some temperature sensors, and a few other things. The benefit to serial is that there's a lot more sensors that use it, and they also allow for more complex features. So most of the time, if you're using one of those interfaces, you will be using a library for the sensor. And then, yeah, most sensors have libraries to make interfacing simple. Like I said before, if you have a sensor and you want to know how to use it, there's a good chance there's both a guide and a library already written for it. So a few more pieces of electrical safety that are needed when interfacing with sensors. Voltage level matching. So the Arduino and sensor both need to be at the same voltage to work correctly. So for example, all of our robots use a 5-volt logic for the Arduino. So if you connected a sensor to it, you need to make sure it is safe to be connected to 5 volts. A lot of sensors, a lot more modern sensors are running on 3.3 volts now. So if you have to use one of those, you'll have to get extra circuitry to make sure everything stays stable. Common ground. So ground or 0 volts is just the reference for the electronics to know what 0 is. So if those aren't connected, if the sensor and the Arduino aren't connected together on ground, the Arduino doesn't know what the sensor thinks 0 volts is, and it won't know how to interpret the signal. Another example of this is you have to have a complete circuit for electrons to flow. So to get the actual control circuitry to send signals, it has to have a return path back to grounds. And then a few mistakes that are common when troubleshooting sensors. 1 second. A few mistakes when troubleshooting sensors. Always check to make sure the power pins are the correct polarity. So sensors most of the time have a positive and a negative. So just make sure that when you plug those into the Arduino, you have those correct, or you could easily burn something up. To also double check the communication wiring. So A lot of sensors have 2 or 3 pins for communication. If those aren't 100% correct with the code, it will cause it to either give you bad data or just no data at all. So motor control, for iRobot, we use the VEX electronic speed controllers. So these speed controllers use something called PWM. PWM just stands for pulse width modulation. It's a digital format for sending data by varying the time between pulses. So if you look at the graphic down here, for example, full reverse is 1 millisecond or 1,000 microseconds between pulses, well, pulse width. 1.5 or 1/1500 microseconds is stopped, and then 2,000 microseconds or 2 milliseconds is like full forward. The servo.h library is very helpful for this because it just has a command for sending microseconds. So I'm gonna go ahead and show that off here. A little example here. So to start out with, to include a library into Arduino, it is just up on the Sketch tab. We'll go to Include Library, and then it'll show up all the libraries that are default Arduino libraries. So the Servo library is a default Arduino library. And also, if you have any libraries you downloaded from either the library manager or the internet, you'll see down here contributed libraries. So we'll go and click Servo. I already had in there, but this just tells the code that we are going to be using functions from this library. Here I have the motor pin. So define does the same thing as a variable, except it can't be changed during the running of the code. So essentially, all this tells the compiler that when it's translating this to machine code for the Arduino, that to replace every instance of motor pin with the number 2. This just makes the code a little easier to look at. And then servo motor. So this is just defining the servo class. So you would type in servo, which is the name of the library, and then what you want to call your servo. So here we have mtr for motor. And then in the setup, all you have to do is motor.attach, and then the pin. And then down here in the loop, you'll notice we have motor and then dot right microsecond. So as I was saying before, servos or ESCs want between 1,000 and 2,000 microseconds. So in this example, we just have it sending 1,200 microseconds, waiting a second, and then sending 1,800 microseconds. So I'll go ahead and swap cameras here. All right. So I have just a basic servo here. I don't have any of the ESCs I show it with that, but we're just going to go ahead and wire it. So a common thing with servos is they have a 3-pin cable. So there'll be a gray, red, and a orange. Or the brown, I guess. Brown and red are the 2 power. So brown's obviously ground and red is positive. Also, I will say, if you ever do anything with actual robots, don't plug in the servos directly to your Arduino. A lot of servos pull a lot of current, so you need to make sure you have dedicated 5-volt supplies like we do on the Go Build a Robot. Plug that into 5 volts. And then this, we look back at our code, and 2, also another good thing to do, unplug your Arduino before you start wiring into it. So we're just going to do a quick sanity check. Pin 2 for the servo wire, and then 5 volts and grounds. So we'll go ahead and plug the Arduino back in. Keep that centered. And then we'll run back over here to this IDE, make sure we have the correct Arduino. So I'm using Arduino Nano, right port. Then we'll click upload. It'll compile it and then it should upload it. All works well. Yep. And then now, if you look back over here to the servo, it's just rotating back and forth between what it has defined 1200 and 1800 microseconds to be. So if this was connected to a VEX ESC like the robots use, that would be going backwards and then going forwards. Go ahead and unplug that for now. Change our condition. Perfect. All right. So have another example here. Go ahead and pull that up on how to use. I don't have a slide for this, but how to use. That it? Yep, that's it. How to interface with buttons on the Arduino. So sometimes you might use a button for, say, a limit switch, or a lot of proximity sensors will have a 0 or 1 as like just an on or off as a signal. So this piece of code here, a little better, just has a button connected to pin 7, and then it will, for using buttons, you want to use something called a pull-up. A pull-up is just something built into the Arduino that allows it to pull that signal up to 5 volts when it doesn't have anything acting upon it in the real world. So the reason you want these is there's always static electricity, the 60 hertz like main parasitic power just around, and also your hand has a little bit of power connected to them. So you want to have a pull-up just so it doesn't just keep bouncing back between low and high on its own. So that's what that's for. And then obviously there's another pin mode. And then serial.begin, that's just to start the serial communication so it can see what it's doing. And then down here, we just have a simple if statement. I won't go too far into these. I think session 4, we'll get a little more into if statements. But essentially, if the button is being pulled down to 0, or if it's being pulled low, it will then print to the serial screen pressed. So we'll go ahead and swap cameras again so I can show you that. So if you look here, there's just a button, and then it's just connected to the ground and also to pin 7. Go ahead and plug that back in. Get the servo motor out again. And we'll go back up here, make sure we're on the right port and the right type of board, and then hit upload. So another use you might have for a button is if you want to see if you've, for say, like hit something with the robot, you could put one of those on like the very corner, and then if it hits something, it presses the button, and then you tell, oh, you're actually you accidentally hit something. Then go to the serial monitor, and now I'm going to press the button. The Arduino sees pressed. So another thing about buttons, if you notice, every time I click it, it has a whole bunch of instances saying clicked. So buttons have something called bouncing. So even though it looks like we're just going on and off, every time you press that button, it actually opens and closes like hundreds of times. So a lot of times you will have to do debouncing in code, but for a capacitor across it. But for this demonstration, I'm not going to. But also, another reason it's doing that, if you notice, there's no delays. So it's just looping through this at 16 megahertz, which is the Arduino runs at. It's just constantly checking if that button's been pressed. So if you think about it, it's checking that so many times a second and then pressing that field, which is why it's giving a whole bunch of communication. I'll just leave it on the document camera for the second and bring back up the slides. So yeah, that was controlling a motor. Like I said, we use PWM for the ESCs, and it has a range of 1,000 to 2,000 microseconds, with 1,000 being fully backward, fully reverse, 2,000 being full forward, and 1,500 being stopped. So another type of sensor you might want to use is something called an ultrasonic range sensor. So this will give you the range in centimeters away from the so for example, you might mount one of these to the front of your robot, and then tell it to go until it reaches a certain distance from something, or if it's about to hit something. Let's go into the code. For this one, I'll actually write it from scratch, just to show you guys that process. All right. So start out with, there is no built-in libraries for these sensors. So the sensor we're using is a HC-SR04. I will see that there. So a quick common way just to search it, if you go into the library manager in Arduino IDE, which is a little books, just type in HC-SR04, hit enter, and you notice a whole bunch of libraries pop up. So the nice thing about Arduino is they're so popular, and a lot of these sensors are just very popular as well. A lot of times there's already code written for them. So for example, I went ahead and downloaded the HCSR4 by Martin here. You just hit the install button, and then I'll just remove it so we can show that process. You'll just install it, and then it'll come down here, say processing, and show a bunch of stuff there. And it takes a minute because it's downloading from the internet, but it'll just continue going. Another thing is if you don't find one there, go ahead and bring this back up. Is you can just type in HCSR04 Arduino library with your favorite web browser, and a whole bunch of things will pop up. So, for example, here is one from Arduino, and that'll show you the project hub of Arduino, which will show you a nice guide, what kind of things you might need. It'll load. Yep, there we go. And it'll show you all your wiring diagrams and all that. That's another great thing about Arduinos is a lot of people make guides for them. So you can very quickly find information about them. And if you need a library, so down here, the first one, GitHub is very popular for sharing libraries and code, stuff like that. So you might find a GitHub library, and it'll show, for example, documentation about it, which is always a README. And it'll show a little bit about the code, what a basic program for it might be, stuff like that. Also, just so I go ahead and show you guys how to actually install a library from the internet. It's a little bit different. You'll have to actually download as a zip file. Let's save and all that. And then once you're back in your Arduino, you go into Sketch and then include library. And you'll notice add zip library. So open that and then find wherever that zip file you just downloaded went to. Open it up, then come down here, say library installed. Sometimes when you download libraries from the internet, it'll say something like this zip file doesn't contain any files or doesn't contain a library. Sometimes it'll accidentally download it into another zip file. So it'll be a zip file inside of a zip file. So you may have to unzip it and find the file you actually need. So just something to look out for. But anyway, say you just got a new library and you don't know how it works. There is the examples tab. If you notice down here, examples and custom libraries. So we scroll down, we find the HCSR4 ultrasonic sensor, and you'll notice a few different options. So we'll go to the first one here. And I'll have to share that screen as well. Take a minute. And then it'll show, for example, what has something to do. It must have comments saying what each command from the library does. Just another great way of learning how to use new libraries. Go and close this. The one example I have uses a different library. Share the one I need. There we go. So go in here, and then we want to include our library. So scroll down here. I ended up using the HCSR4, just a normal library there. And then I like to go ahead and define what pins I'm going to use for my sensor. So the HCSO4 has 4 pins. It has a VCC and ground. VCC is just another word for the positive voltage supply. And it also says echo and trig. So these work by sending out essentially sonar. So they have an echo, and then when that it receives that echo back, it'll send out a signal on the trigger. So we'll just set the echo pin to be pin 8 and the trigger pin to be pin 9. And that's just so we don't have to type in 8 or 9 later. We can just type in the variable. And second. So then type in this library uses a second, I gotta make sure I'm typing this right. Oh, that might be why it's not right. Ultrasonic. Just gonna copy this in from previous work here. Sonic, then ultrasonic, and then system sensor. And then we have these attached to, not mistaken, sometimes they'll pop up and we say, I think echo first and then trig. Double check that because it doesn't seem to want to be auto-filling like it normally does, but I will. And then, oh, I've also made a mistake there. That's just a defining of the class. We need to put that above our setup. And then down here at setup, we're just going to start serial again so we can write out the values it's receiving onto our screen. And down here in the loop, we're just going to print out the measurement distance. So it's distance sensor dot measure distance and cm per centimeters. And because that's a function, you always have to put in the two afterwards, even if it's not taking anything in. And then we'll just put in a simple delay so we're not getting that a whole bunch of times. Another thing with Arduino, it's always good just to put a very small delay in, just so it's not, sometimes if you don't, it'll like start errors and not giving accurate results. So we're going to compile that to see how many mistakes I made here. Oh, wow, none, surprising. And now we're going to go look over here at Arduino. We now need to wire this in. So I'll go ahead and just leave the button in there for now. But starting out with, take our ground pin, plug that into the ground pin on the Arduino. Then we'll take our VCC, plug that into 5 volts. Then our echo pin is pin 8. Echo here is the purple wire. Plug that in to pin 8. And then we'll put our trigger into pin 9. Yet again, make sure you have your Arduino unplugged when you're doing wiring. I did not there. Then I'll basically go back up here to the port, make sure we have the right one selected and the COM port is the right one. Then we'll hit upload. Work fine. Yep. Then we open our serial monitor. We're noticing -1. So if you see -1, a lot of sensors or like vibrators will put a -1 with an error. So my guess, I have my wires reversed here. Go ahead and close that, unplug it. We'll just try reversing our echo and our trigger here. Plug it back in. And if we look back at the serial monitor, yep, now we have a 3.74. So look at the sensor currently. Let me make sure my camera is still correct here. Yeah, if you look at the sensor currently, it's just immediately facing the breadboard, so it's just getting that 3.7. But if we, for say, turn it around and point it back at my wall, now it says 30. which is about accurate. Or we point it up at the camera, it says about 26, 25. And then if we just point it off into space, up into the ceiling, you'll notice that it goes about, just starts sending out 94, 87, 79. So these sensors aren't very accurate at the um, super long distances. But for example, pointing at like up to about 50 to 80 centimeters, they're pretty good. So now we're going to combine the two things we just did here. We're going to make it where the motor will turn to what would be going forward on the ESCs until it detects a distance within, say, 10 centimeters. So we'll need to include our servo library again. And then all times, autofill, but today does not want to. And then yet again, we'll have to do our servo declaration as motor. Also go ahead and define our pin name here. Pin 2 again. I'm going to do them here in setup. We'll just do motor dot attach to motor pin. And then we're going to come down here a loop here. And then we'll just make a simple if statement. So if the distance sensor dot measure distance there, it actually autofilled. Is, for example, let's say less than or equal to 10 centimeters. We will motor dot right microseconds. I think that's the right syntax for that. Let's double check here. No. So make sure I have capitalizing correctly. Then we'll do 1200 if it doesn't. Actually, we'll do 1500 for stop if it detects it. Then come down here and we'll just do a simple else, which just means if the if statement isn't being triggered, we will write to a full forward or 2000. All right. Then obviously we want to keep our delay in there. We'll keep the serial printing for now. Let's go back over here to our Arduino, and we'll plug our servo back in. It's for visuals. Plug in our 5-volt signal again. Like I said before, don't ever actually plug in a servo to an Arduino. It's not great practice, but it does sometimes work for just quick little demonstrations. And then we have our servo hooked into pin 2. Then we'll plug that back in. Put it back in. Perfect. $200. Now we'll go back over here, make sure all of our ports and comms are selected. Uploaded it again. Compile it. Maybe probably see how many. Oh, no errors again. Surprising. And now it's uploading. Done uploading. Perfect. So now it's 3.62. And if you notice, servo is at the stopped position. But for example, if it sees, say, 25 or 30, it's going. But then say we inch it forward towards the wall. 14, 7. There we go. And now it stops. So these can be used, for example, when doing autonomous code. So say you had you needed to go forward until you were a certain distance away from like a wall or a gate. You could have it program it in to just drive forward or drive like a series of lefts and rights, and then tell it to stop when it gets to a certain distance. Also, you can do arrays of these sensors and have, say, you have like 3 or 4 on different sides of the robot, and you can visually map where everything's actually at. Do some a lot more advanced code there. All right, we'll go back to our slides here. wherever I put those at. Go. Share these. Yeah, like I was saying, there's a little wiring diagram for the for Arduino Uno. But another thing to keep in mind with these ultrasonic sensors is that this particular one does not go down to 3.3 volts. So if you were to swap the main controller board down to a Arduino that runs on 3.3 volts, you'll have to change sensors. I want to say that's everything. Go back here and make sure I touched on everything. Yes, I have. So another thing I want to just touch on is there it is. So when using sensors that are 3.3 volt with a 5 volt Arduino, you can use something called a level shifting board. So let me just bring one up here so I can show that off.
Cody, can't hear you.
Oh, well. Let's see here. What has happened? Let's see. Any better now? Is it working now or is it still bad?
Yes, I can hear you now.
All right, sorry about that. Came unplugged. Anyway, back to what I was saying. Go back to there. Sometimes you'll find 3.3 volt sensors that you would like to use with a 5 volt Arduino. So they make things called a level shifting board. Let me convince that. So let me get a new tab here. So I can show a visual off here. Yeah, one like that. So if you ever want to use a sensor, say you find a ranging sensor or like a time of flight sensor, which is like a more accurate ranging sensor that only works on 3.3 volts, you can get one of these boards, and essentially you can just use it. You just plug in one side from your Arduino, the other side to your sensor, and it will stop and make sure everything is at the right level. These are actually very handy to keep on hand, or especially if you're planning on interfacing with a lot of different sensors, because a lot of new sensors only come at 3.3 volts as the industry is slowly shifting over, but Arduino is still run on 5. Let's see here. Another thing I want to touch on, sometimes sensors will use serial communication, but don't actually end up using I2C, UART, or SPI. So for example, the ultrasonic sensor we're using today had echo and trigger. These are a type of serial. It does communicate with serial, but for example, it's not one of the examples shown. So that's the reason that external libraries make all of this so much easier. I think that was everything I wanted to touch on. Yep. So, does anyone have any questions?
I do have a couple questions that's for later though. I think this is for after the class.
Alrighty. Anybody else? It doesn't exactly have to be about what I said. If you have any questions really about any Arduino stuff or issues with robots, feel free to ask them. What these sessions are for.
Okay, so I think I'm having issue with all my libraries. It's probably not even loaded, right? So is there any way our first codes had some kind of issues with it prior to us leaving, and I just want to know if there's any other like updates on that, because sometimes there's a glitch.
For the stutteriness, yeah. So we're still working on that. Hopefully we'll have that to you soon. Another thing that you might want to check is just to make sure all your wires are like securely attached. I'm sure you may have already, but yeah, we're working on that currently. But so far, no updates.
Oh,
We'll let
okay,
you.
gotcha.
Yeah. Sorry about that, by the way. Just the nature of these things sometimes.
Okay, I think that's the only one. I'm just gonna have to re-upload the libraries that I got into the Arduino's IDE.
Yep. Well, if there's no more questions, I'll go ahead and end this recording. Where is this button? Or stop recording.